Hello everyone, welcome back to my channel. For today's session, we will see how to implement a circular queue using linked list. So when you want to implement a circular queue using linked list, we are going to use a circular linked list. Because in case of your circular queue, your rear is connected to the front. So this structure is present in case of your circular linked list. So that's why for implementation of circular queue, we are going to use a circular linked list. So again for queue, we have the one end that is nothing but the front and we have another end that is nothing but the rear. In case of circular queue also, we are performing deletion operation from front end and we are inserting a data at the rear end of your queue. So the node structure we are going to use here is nothing but we are going to consider a data as well as a next pointer. And just to maintain the front and rear, we are going to use a two pointers that is front and rear. And at the start, we are going to initialize it with the null. Now we will check the operations for circular queue. So first operation is nothing but enqueue operation. When you want to perform the enqueue operation in case of circular queue, that means we are performing the insertion at the rear end. So for that, first we will allocate the memory for inserting a new node. After that, we will read the data for new node and assign the data to the new node. After that, we have to check whether your queue is empty or not. If your queue is empty, that means you are inserting the first node of your queue. So how you are going to check your queue is empty? So you can check with the help of front equal to null. So if your front is set to the null, you can say that your queue is empty and whatever the new node you are trying to add, that become front as well as rear for your circular queue. As well as we need to set a rear end is connected with the front end. So for that statement, that is rear next equal to front, or we can say that new node next equal to front. So these statements are used. You can use either new node next equal to front or rear next equal to front. So this is the first case when your queue is empty. Now we will check a second case. Second case is nothing but your queue is not empty. So you can see here you have the circular queue with element 10 and 20. I want to insert this new node 30 into my circular queue. So I will add this new node at the end of my circular queue. That means I am adding after rear end. So for that I need to make a statement rear next equal to new node. After that, when you are going to add the new node at the end of your circular queue, this new node become new rear for your queue. So this rear will be removed and it is updated with this 30. For that rear equal to new node, this statement is given. After that, if we are talking about a circular queue, we need to set a connection from new rear to the front of the circular queue. So for that, rear next equal to front, this statement is given. Hope so it is clear to you how to perform enqueue operation in case of your circular queue. Now we will check for the dequeue operation. So when you want to perform dequeue operation in case of your circular queue, again we are deleting a node from the front end of the queue. So first, there are three possibilities in case of dequeue operation. First is queue is empty, second is queue is having a single node, and third is queue is having more than one node. So first case, if your queue is empty, deletion operation is not possible. So how to check your queue is empty? You can check it with the help of front equal to null. Now the second case is nothing but your queue is having a single node. So now the question arises how you are going to check your queue is having a single node. So when you are talking about a circular queue, you can check it with the help of front next equal to front, or you can check rear next equal to rear. And if your front and rear both pointing to the same address, you can say that your circular queue is having a single node. So in that case, if you are trying to delete that node, you need to first set a temporary variable with that front value. After deleting, you need to set the front and rear to the null. If you want to print a data, you can print it with the help of temp data. And whatever the memory is allocated for that single node, you can free it with the help of free temp. So that was the second case if your circular queue is having a single node. Now we will check a third case. Third case is nothing but your circular queue is having a more than one element. So this is a circular queue having element 10, 20, 30 and 40. And I want to perform dequeue operation. That means I am going to remove the 10 from this circular queue. So first thing, I will hold that front into a temporary variable. After deleting this front, I need to set this 20 as a new front for my queue, as well as I need to create a link from this rear to the updated front. So first I will update a front with the help of front next. So for that statement is given front equal to front next. After updating front, I will go for setting this rear next to the front. This link will be created. So rear next equal to front. This statement is given. If you want to print a deleted node, you can print it with the help of temp data. And whatever the memory is allocated for this node 10, you can free it with the help of free temp. So this is about how to perform dequeue operation in case of your circular queue. Now we will check for the display operation. So if you want to display a circular queue, there are again two possibilities. First, we will check your queue is empty or not. If front equal to null, we can say that your queue is empty and nothing to display. If your queue is not empty, in that case, we are going to use a while loop and print a data. I want to traverse this circular queue. So I will hold a front with a temporary variable. After that, I will use a while loop temp not equal to rear and I will able to print a data 10 and 20. And after that I will print a rear data separately. So this is the first way to display a circular queue. You can use do while loop instead of while loop for printing a circular queue. Hope so it is clear to you how to implement circular queue using linked list, that is nothing but circular linked list. Thank you for watching. If you like this video, don't forget to subscribe my channel. Thank you.